Welcome. Today we'll derive the formula for integrating x to the n times e to the x using integration by parts. Let's start with our integral, the integral of x to the n times e to the x dx. To solve this, we'll use the integration by parts formula, which states that the integral of u dv equals u times v minus the integral of v du. For this integral, let's choose u equals x to the n and dv equals e to the x dx. These choices will help simplify our integration. Now we need to find u. The derivative of x to the n is n times x to the n minus 1 dx. And for v, we integrate e to the x dx, which gives us e to the x. Let's substitute these into our integration by parts formula. The first term will be u times v, which is x to the n times e to the x. Then we subtract the integral of v times du, which is the integral of e to the x times x to the n minus 1 dx. Let's simplify the second term. We can bring the n out front of the integral, since it's a constant. This gives us our final form x to the n times e to the x minus n times the integral of x to the n minus 1 times e to the x dx. Notice that the integral in our result has the same form as our original integral, just with the power of x reduced by 1. This means we can use this formula recursively to solve integrals like the integral of x squared e to the x or x cubed e to the x. This formula is a powerful tool for solving these types of integrals. Remember, each time we apply it, we reduce the power of x by 1, making the integral progressively simpler until we reach a basic integral we can solve directly.